As a virtual vehicle, we wanted to demonstrate an object detection application using the knowledge graph-based data integration framework. The purpose of this use case was to test the Evolve platform. So we wanted to test loading and accessing large amount of data, deploying various container services to replicate our local instances, testing and comparing different object detection methods, and comparing the local execution performance to the parallel execution performance in the platform. For this reason, we first deployed context and stack using YAML-based service templates. Then we imported Lyft and Motional datasets. We executed different object detection methods over data through accessing knowledge graph. And finally, we implemented parallelization using Argo workflows.
First of all, we need to log in to the Evolve platform. After the login, we will reach to the services screen, which provides us a list of services that are currently running in the platform. Our architecture for context sense stack consists of different containers which uses different images. For example, some containers are using official images like RabbitMQ, Knowledge Graph, which is a Neo4j graph database, and PostgreSQL for storing application-specific data. Other containers listed here, which are light blue boxes, are provided from our company. They are developed in the company, and we developed our custom images for these applications, and we use these custom images to deploy these containers. Context sense libraries are included in the repository and in the notebooks as a tool for easy access to the knowledge graph and some functionality provided by the stack. Repository is a Django-based application for doing some application-specific operations and storing data to the PostgreSQL. And Notebooks is a custom Jupyter Hub installation which allows users to access to the knowledge graph and to all the functionality of the stack using Jupyter Notebook servers. Algorithm Execution Engine is a salary worker for doing some asynchronous tasks over the stack. To deploy these services, we are using the templates provided in the platform. These templates provide some official services to use directly in the platform. To start them directly just by creating the service by clicking the buttons on the platform. But it is also possible to create additional templates. For example, these listed templates weren't available in the platform, and we have written them using a very simple YAML language. Here you can see the Algorithm Execution Engine template, which using our own custom image and some configuration taken from the user to connect to other services in the platform. And here you can also see some Neo4j template which is using an official image directly from the Docker image repository. One critical thing to remember is that for some services that are too complex to create, like Jupyter Hub, it is also possible to the flexibility of the platform. In that case, we have used Helm charts to install the Jupyter Hub and to deploy it on the platform. This is very possible using some additional notebooks and running some scripts in these notebooks. We are using two open datasets based on nuisance data format. First one is from Motional. It contains 1000 driving scenes. Each of them is around 20 seconds. And the second one is from Lyft. It is level 5 open data perception datasets. The common advantage of these datasets that they use the nuisance schema, which consists of different entities and relationships between these different entities. So we uploaded these datasets to the file section. In the Motional folder, you can see that all this data is stored in JSON files for different entities. And also we have the images in the samples folder and LiDAR swaps in swaps folder, and we have the maps folder. Additionally, also in the Lyft folder, which we uploaded all the training data set, we have the training data for different entities in JSON files, and also we have images, LiDAR, maps, data stored here. After uploading this data, we need to import the data using, which we call them adapter, using some Jupyter notebooks for loading all the data separately. So this Adapters can work with any kind of nuisance-based datasets. First of all, we have some definitions of functions. We connect to our graph database, to our knowledge graph. We define the input folder. Then we define some common attributes to somehow categorize the same uploaded data together. And then we have some constraint defined in the database using Neo4j queries. Then we generate node queries based on the data schema, which is defined here. And then we execute these queries on the Neo4j graph database, and then we are starting the relationship queries. We first loading the nodes so that relationships would find the corresponding nodes when creating the relationships. When this loading process is finished for both Motional and Lyft, it is possible to see all the data in the Neo4j browser. You can see here we just selected the scene, and these are the samples around these scenes, and there is one log attached to this scene. And you can see all the attributes, categories, all the entities listed here with their relationships. When we upload these two datasets, we get around 7.5 million nodes and almost 20 million relationships. So it is a bit large dataset, which is really good for testing the Evolve platform. Now let's do an object detection algorithm demonstration using the context and stack and the knowledge graph that we imported. So we are going to use the sample data that we imported. This sample data file path is important because we are going to use this file path in our notebook to apply object detection algorithms and getting the results from it. So let's switch to the Jupyter Hub. This is the Jupyter Hub, which is part of the context and stack that we deployed previously. So first of all, we are running the first cell for loading required libraries. And then we can connect to the graph using the graph access. Here, these three lines are important because these are the context sense libraries, which is part of the context and stack. And they are directly installed in the Jupyter Hub, in the Jupyter Notebook servers that are part of the Jupyter Hub. So they provide some basic functionality for applying, for example, YOLO or TensorFlow Hub object detection models. And also additional functionality for accessing knowledge graph. So after connecting, we can easily get some nodes based on the labels. Let's say that we want 5 sample data. We can run this cell and we can get 5 different sample data, which are taken directly from the knowledge graph. We can also filter out based on some properties. For example, we are only interested in JPEG format, and we can just run these 335 sample data, which are JPEG format. And let's use the same cipher that we used on the browser to get this image path. We will just run query, and then we can see the image using this cell. This is the image. It contains some traffic lights, some cars, etc. We will run the YOLO, and this is the result of the YOLO. I'm not running now because it may take longer. So for the demonstration purpose, I'm just showing the result here. So this is the YOLO result. You can see that 4 traffic lights are detected and some cars here. We can also run different TensorFlow Hub models. We will run first efficient DET. This is the result of it. These traffic lights are not recognized, and these cars away is not recognized compared to YOLO. And this is the faster RCNN. Now we have something here. They seems like persons, but probably this is just wrong detection. And this traffic light is also not detected. And this is the CenterNet hourglass. This here also we can see that here is a track which is not recognized by YOLO, and here is something like traffic light. It is hard to distinguish if it is correct or not. Now we will show how we are using parallelization from the Evolve platform. For that, we will use the Argo service. Argo service provides some workflows to easily implement some parallelization. So here we have a object detection workflow template, which consists of 3 steps. First step is for retrieving files from the knowledge graph. The second step is processing each image that are retrieved in the first step. And the last one is the creating nodes on the knowledge graph, which will be the result of this object detection. Let's submit that for 50 images, which means that the first step will try to bring 50 images from the database, and then it will create 50 different nodes for running each image, each object detection over the image. So it is going to use the default object detection, which is the YOLO version 4. Here you can see that we have 51 tasks in progress. One is already finished, the others are currently running. In the meantime, let me show you our previous experiment results. So these are 4 different object detection models that we used. Blue lines are for local laptop using normal approach. The second one is using optimized version. The green is the one that we implemented everything as containers and run them on a virtual machine. The yellow is virtual machine optimized version, and this navy blue is the Evolve platform. So you can see that mostly Evolve platform provide us very good performance capabilities when we use parallelization. So let's go back to the parallelization. So it is already 38 ones already finished. So let's wait for a few seconds more to see that all tasks to be finished. Still, we have some seconds to finish. And actually, you can see all the events that are occurred, what kind of environments they are using, which images they are using, what kind of outputs there are, if it is already defined. And the last nodes are still ongoing, so you can see that which kind of file parameter they are using. You can see the events here, and you can use here to go back to the previous screen. And we are now at the end. We are waiting on the one node here. Yeah, so it is finished. So it took only 2 minutes.
Additionally, we did a small transfer learning experiment using Evolve platform. We retrained an object detector from the TensorFlow Model Hub using transfer learning techniques. We did 2 demonstrations. In the first one, we utilized synthetic data, and in the second one, we utilized real-world data. When we use synthetic data, we got lower confidences of detections and more false positives. And when we used real-world data, we got higher confidences of detections with more correctly localized and classified objects. Based on this experiment, we can say that we have some benefits of using Evolve platform for transfer learning in deep neural networks. For example, the local resources were insufficient for experimenting this retraining in our local machines. And also we tested on Google Colab environment using free subscription, which GPU resources weren't enough because we got frequent crashes and long training times, almost 6 hours for the baseline demo. But training on Evolve platform only took 1.5 hours, which shows a 4 times performance benefit. It is a significant advantage even over the Google Colab session. So that shows that we have clear benefits of using the Evolve platform. Nevertheless, we can say that by using Evolve platform, access to the data is simplified and unified. So users can extract and explore the data using the knowledge graph on the Evolve platform. So everything can be done through the Evolve platform using the benefits of high performance computing. Datasets can be stored on fast storage. Context sensors are easily and efficiently deployed on Evolve platform, so all containers can be easily and efficiently deployed on the platform. It also platform provides easy to use and efficient parallelism using the Argo workflows. So storing the detection results, for example, based on the object detection, creates new possibilities. So additional data can be put into the knowledge graph, so that can be used in other approaches accessing to this data. So allows historically to check results and compare versions of different object detection algorithms, and helps to keep track of the source of the results. So we can conclude that there is a clear performance benefit using Evolve platform.